A very good day. I'm Veknesh Arumugam, Bachelor of Chemical Engineering with Honors. In this video, I would like to explain my research under title of Synthesizing Green Chitosan Magnetic Composite Particles from Phaneropac indica species for palm oil mill effluent pretreatment. Introduction. A variety of studies has been conducted with different forms of coagulants and flocculants on the treatment of pomade. In recent years, natural organic coagulants have been used as environmentally safe coagulant in wastewater treatment. Natural organic coagulants are environmental friendly products that are biodegradable from organic waste such as prawn shell waste. Chitosan is a high molecular weight cellulose-like biopolymer obtained from chitin deacetylation. After cellulose, chitin is a second research organic material. At present, magnetic particles are widely studied in the area of water treatment. The fine size effect and high surface to volume ratio of magnetic particles result in increased absorption capacity. Chitosan and magnetic particles are interlinkable to satisfy the needs of high absorption, regeneration, fast separation, and cost-effective treatment of wastewater. This study has been conducted as it provides a greener environment to society in long term. Chitosan magnetic composite particles create greener energy and help to develop an environmentally friendly waste management system to minimize the environmental pollution. Besides, as a very useful biomaterial, chitosan has demonstrated considerable potential and can be extracted from a very easily accessible source. This research is being performed with the use of chitosan magnetic composite particles as a part of pomade pretreatment. These composite particles are reinforced in the pretreatment process for better agglomeration, adsorption, coagulation, and flocculation of pomade. Objectives: synthesize chitosan magnetic composite particles from prawn shell, analyze the wastewater quality parameters during startup and end-up period. The wastewater quality parameters included the chemical oxygen demand, ammoniacal nitrogen stability, total suspended solid, and pH value. Last but not least, obtain the optimum dosage of coagulant needed to optimize the wastewater parameter reduction. Methodology. Methodology consists of three parts. First, extraction of chitosan from prawn shell using deproteinization, demineralization, and also deacetylation method. First, deproteinization by use low concentrated of sodium hydroxide to remove the tertiary structure of protein, followed by the demineralization using hydrochloric acid to remove the minerals or inorganic compounds such as calcium carbonate. Last but not least will be deacetylation by used high concentrated of sodium hydroxide to remove the acetyl group and form the amino group, and can be produced the chitosan. Synthesizing chitosan magnetic composite particle. In this method, two chemicals were mainly used to synthesize the composite particle, which is the ferric chloride and ferrous sulfate. The chemical co-precipitation of iron 2 plus and iron 3 plus ions formed the composite particle in the presence of chitosan and the sodium hydroxide ion. Pomade pretreatment. Wastewater parameter will be analyzed, which is the COD, turbidity, ammoniacal nitrogen, pH value, and also the TSS. From the analysis result, can identify the optimum dosage level of coagulant using RSM method of 2D plot. Result and discussion. Chitosan magnetic composite particle synthesis. In this study, chitosan magnetic composite particle synthesis was prepared in two stages, which is the chitosan extraction from prawn shell and also the chemical co-precipitation process in the presence of chitosan. The chitosan solubility in 1% of acetic acid was 88.2% with a pH level of 8.32. The moisture content found in extracted chitosan was 5% with a yield of 81.7%. Chitosan exists in the form of pale pink flakes, which was converted into powders. The degree of deacetylation was tested for chitosan as one of the key parameters, and the DD level of chitosan was 84.9%. The composite particle was synthesized in good quality of range and exists in black color. The yield and moisture of the composite particle obtained were 92.3% and 5% with a pH value of 8.17. Wastewater quality. The key parameters of POME such as COD, TSS, ammunical nitrogen, turbidity, and pH value were analyzed. Startup period, where the POME parameters were analyzed before the coagulation process using the jar test. End-up period, the pretreatment process involved the coagulation and flocculation process by adding the chitosan and the composite particle. In the table shows the maximum reduction of parameter obtained. Dosage of coagulant needed to optimize wastewater parameter reduction. For the coagulant dose, around 12 analytical experiments were performed for the both composite and chitosan particle. In this experiment, the optimum dosage of composite particle that needed to achieve the maximum reduction on wastewater parameter was 4 gram per liter, whereas for chitosan was 5.5 gram per liter. Effect on pH. At the pH of 8.35, the reduction was optimal for composite particle, while at pH of 8.92 for chitosan. The acidic situation of POME contributes to the removal of suspended solid. The suspended solids in the POME are improved coagulated by neutralizing the alkaline coagulant to process the solution according to the typical discharge criteria. Effect on turbidity. The maximum reduction obtained in terms of turbidity was 100 NTU, which is equivalent to 94.6% when used the 4 gram per liter of composite particle. Turbidity value decreased as dosage of composite particle increased. However, when the composite particle were added more than the optimum dosage level, the turbidity value slightly increased because of the excess coagulant create the cloudiness as it achieve its maximum limitation on the coagulation process. Effect on total suspended solid. The maximum reduction obtained when using composite particle was 89.2%, which is equivalent to 2340 mg per liter, compared with chitosan, which is 84.7%, that equivalent to 3320 mg per liter. As turbidity, the TSS slightly increased after added more composite particle than the optimum dosage level. The turbidity and the color of the POME were due to the presence of suspended solid and the organic substance in the POME. Effect on ammonical nitrogen. The maximum reduction obtained when using the composite particle was 63.81%, which is equivalent to 14.67 mg per liter. The efficiency of the ammonical nitrogen removal in the POME can be seen in the figure below. If coagulant dosage increases, it does not affect the ammonical nitrogen reduction much, but the reduction efficiency decreased by 0.45%. This is because the coagulant achieved its limitation on ammonical nitrogen reduction. Effect on COD. COD is an important parameter in water quality as it provides an index for the evaluation of the impact of wastewater. Higher COD level means that the sample has greater amount of organic oxidizable content that decrease the dissolved concentration of oxygen. The maximum reduction obtained when using composite particle was 90.6%, which is equivalent to 4023 mg per liter. When used chitosan, the COD concentration was reduced to 9245 mg per liter, which is equivalent to 78.5%. In overall, chitosan magnetic composite particles are better to use compared with chitosan because it shows the maximum reduction with lower dosing level. Conclusion. In this study, co-precipitation with the involvement of chitosan without any cross-linking agent was used to synthesize the chitosan magnetic composite particles for the POME pretreatment. The highest reduction of parameters for applied 4 gram per liter decreased by 94.6% of turbidity, 89.2% of TSS, 63.8% of ammonical nitrogen and 90.6% of COD respectively. Chitosan magnetic composite particles are better for the Pomey calculation than chitosan because the parameters are much lower with lower dosing levels than chitosan. These composite particles is environmental friendly and sustainable. Besides, the effect of chitosan and magnetic ions in the Pomey pretreatment cycle improve the efficiency of agglomeration, adsorption, coagulation, and flocculation. Before I end this video, I would like to express my sincere gratitude to my supervisor for helping me to publish my research in review paper and research paper. That's all from me. Thank you so much for your attention and lending your time to watch this video.